Hello and welcome once again to Rustic Wires. In last session, I discussed about the difference between the main function in Rust versus C. And in continuation to that, this session discusses about the differences between struct data type in Rust versus C. So I have highlighted five differences here. So few are at the syntax level and few differences are due to the characteristics of the programming language itself. Okay, so let's see what these differences are. So the first difference is that the structure layout is undefined in Rust. So what does this mean is that if the structure has three fields, let's say that the first field is all three fields are int32 and ABC, then in Rust, it's not guaranteed that the memory layout would be in the same order as the structure fields like A, B, C. Okay, so if you want the structure layout to be in the order of the fields, then you have to use this qualifier. Okay, so this is very important if you are programming at the low level where you wrap the structure uh, with the memory mapped register addresses, okay, which is very common at the HAL layer or at the lower level of programming, okay. And in C, the structure layout is well defined and the order of the fields are retained. Okay, and the second one is at the syntax level that in Rust, those struct data type enclosed in curly braces need not be terminated by an semicolon. And the third one is that structure definition and instantiation should be separate in Rust, whereas in C it can be combined. So this is because in Rust you don't have global space variables, or there's nothing like a global namespace. Rust is all about ownership and borrowing the uh, ownership. Okay, so you can't create an instantiation of a structure at the global space. Okay, and the fourth one is the mutability. And so the mutability of the structure is specified when an instance is created. And whereas in C, it's mutable by default. And another major difference is at the visibility level. So in Rust, the visibility can be at the structure field level, and for the entire structure, these two are separate in Rust. Whereas in C, the visibility is at the entire structure level per file. So we will see, okay, so let's jump into the workspace. So I have a simple Rust world application on one tab, and other one is a main.c file with C world. All it does is prints C world in case of C, and it prints Rust world in case of this Rust application. Okay, first I just want to compile and see if this all okay. Yeah, so let's build on this with the Rust sorry, with the struct data type. So first in C, you would create a structure definition. Let me call this as C Struct and with and X and Y. Okay, and in Rust, you would create a struct definition in a similar way. So Rust struct join 32. So there's a warning about the dead code. Let's ignore that for now because the structure is not used anywhere in the code. But as I mentioned, so first this semicolon termination is not needed in Rust, and if you terminate, then it'll throw up an error. Okay, and the second one is uh, instantiation and the definition. In C, you can do something like this is completely legal and allowed. For example, if you compile, yeah, it will go ahead and compile this. But in Rust, you can't create. So to create an instance of the struct, you need to let st of 2 comma 3. It's like x. So again, since these variables are all not used, uh, it'll throw further warnings. Let's ignore that also for now. Okay, there are a few ways that you can get away with this warnings. All you have to do is just copy this, see, and you can just make it not warn about these unused variables. But I don't want to do that now because it, we will soon use these variables. Okay, so this is how we create an instance of the structure in Rust. And in C, you can either create the variable along with the definition, or you can also do in many ways like struct C struct and the CT1. Then you can write CT1 dot x to CT. This is just one of the way, and there are many ways that you can create the variable with the values in it. Okay, so this is the instantiation and the uh, structure data type definition can't be combined in Rust. And regarding the mutability, now in Rust, if I want to modify the, let's say that x equal to before, if you want to modify this field, then it should open error. That's because I haven't set as a mutable variable, so I need to just make sure it's mutable, then it should be fine. Okay. On the C, it's always mutable. Now coming to the visibility, so you can make this structure as static so that the structure is visible only in this file. And in Rust, you can, to make this structure data type visible outside the module, you declare as public, and this would make the structure data type visible outside the module. But if you want to access these fields, then each field has to be public individually as well. Okay, this is perfectly fine. So if you enclose this in a module, and then if you want to use the data type outside the module based on the need, whether the structure definition or structure data type alone is enough, or you want to access the individual fields. So the visibility is both at the entire or the structure type as well as at the individual fields as well. Okay. Now coming back to the key difference which I pointed out regarding the structure layout in Rust. So when you create an structure object here, it's not guaranteed that the memory layout would be in the same order of these fields. So for example, if this, no, okay, let me have an 32-bit address. If this object is located at this address, then this should correspond to X, and so this address should correspond to Y. But in Rust, this is not guaranteed. Okay, so this is very important when, if you, it's common in low-level programming, you wrap a set of memory mapped registers like a UART control register and UART enable register address as a structure, and then you access those by accessing the individual fields. So this order is very important. So in Rust, by default, this is not guaranteed in this way. It can be the other way as well. So that's why it's undefined. But if you want this to be in the order of the fields, that can be done with an qualifier, which is like you just represent, making the compiler to represent in the C format. Okay, something like that. So what this would do is this would ensure that the memory layout would be in the order of those fields. Okay, so that's about it, and thank you, and see you in the next session.